This is a GNSS base and receiver, or ROVER, that you can build for yourself, including the antennas, for $544, and that includes tax and shipping. Most of these parts were bought on AliExpress, and I can provide the links in the description below. It's based around the ZED-F9P board. Two of those cost $240. Those will be programmed in uCenter, and they are connected to these bigger boards, which are the STM32F407. Two of those plus shipping cost $44, and those are used to data log onto the SD cards. They save both UBX and CSV files. This is intended to be used for PPK, so the base will be logging a raw file the entire time, and that will be used to post-process. This is intended for drone workflows for shooting ground control points. So you'll have your base, which is also using a Holybro SICK radio, and that is transmitting RTCM corrections to the rover, which also has a SICK radio and is receiving those corrections for an RTK fix, so you can shoot the ground control points with your rover in RTK fix. And I even designed an Android app to be used with the rover, which has a HC05 Bluetooth module, which is how it communicates with the phone, sending NMEA messages. As you can see, it is connected now. It's asking me for my rod height. You can also add a text file to the SD card with your rod height. And here it's showing my position as well as my fixed type, lat long. It's telling you what file is writing. This will also save your CSV file onto the storage on your phone, as well as you can use the interactive map. These are points that I shot before when I was RTK fixed. Obviously I'm inside right now. I'm not going to get an RTK fix. Also, the base needs to survey in its position. You can see that it's still surveying in, and it will do it for a set amount of time or to a set accuracy until it actually starts getting the RTK fix between these. But this is a point that I stored before, so let's click on it, and you can attach a photo to it. Here it tells you all the details about it. This rover also has a momentary switch, which when you press it, it starts averaging your point. As you can see in the app, it's averaging, showing you the number of reads as well as the horizontal and vertical standard deviations in meters. And you can use the switch, or you can also hit the button to store it. And it's actually also got vibration and sound in the app. I'll turn it on so you can hear it. And what it's doing when I hit the store point is it's sending a command to the rover to start logging the point onto the SD card. And it's also, for each point, it's logging a raw file as well as creating an averaged point for the CSV list. So you'll have a bunch of .ubx raw files for each point, as well as a CSV export, which includes all your point numbers and the coordinates that are averaged from your readings. And you can average it for as long as you want. Typically, if you were RTK fixed, you'd probably be doing 2 to 3 minute observations on each ground control point. And let's see, store point and store point. These OLED displays are pretty useful. They tell you a lot of critical information. As you can see, it tells you the file that's logging, tells you how many satellites, your fixed type. It'll also give you error messages if the SD for some reason isn't writing properly or it drops bytes. But yeah, this is going to be the first video in a series. Obviously, I'm not going to go into too much details on the build, but I wanted to show you the low cost. This is the bare minimum cost, and if you want to make these enclosures and make it a full kit, you could spend $661.77. That includes shipping, which for an entire survey grade base and rover setup, I mean, you can't even buy an Emlid Reach for less than $1,000, let alone having two of those. So also I added a price to, if you wanted to get 2 survey rods as well as a phone. This is a Android phone that I bought. It was $100 just to run the custom app. So if you wanted all that for a full field ready build kit, $826.30. And I also want to give credit to a YouTuber by the name of Skyhorse Tech. He's the one who came up with the idea to use these enclosures as well as configuring the F9Ps. However, his setup is more RTK focused, which you can totally do with this if you export your UBX, or transmit your UBX to a computer over the SICK link, and then you can use an N-trip caster to live stream your RTK corrections over a hotspot. I wanted to make this field kit so that you don't need a Wi-Fi hotspot. You get RTK corrections over the radio link between these receivers, and you don't need any internet connection. And it's also a PPK focused workflow. So if you're flying a drone, you will be using the base raw file to later post correct the RTK instead of having live RTK fix. So yeah, I'll try to make some more videos of this, and there's also a GitHub post that I created. There's one for the base, one for the rover, and there will soon be one for the Android app. You can download all the STM32 flashes. All you need is the ST, I believe it's called Cube Programmer and Cube ID and Cube MX. Those 3 programs, as well as you need the U-Center app to configure the F9P boards. And I've provided wiring diagrams for each of these. Obviously, you'll need Bluetooth or USB power. The STM32 and the F9P board both need their USB power. So yeah, I'll try to do a more detailed video on this build. I just wanted to get this out there. So thank you for watching, and I hope you enjoy this affordable base and rover setup.